Good morning, ladies and gentlemen. In my last class, I have covered the critical point on a single leg and also a constant wind. In that class, I have also covered the derivation of the formula to calculate the distance to the CP. If you have come here for the first time, then I would suggest you to watch the previous video first and then come back to this class so that you have a better understanding. So we will talk about the critical point or a equitime point on a multiple leg, or even if the route is a straight route, if there is any difference in the wind velocity or the direction at different parts of the route. I request you to watch till the end of this video so that you will be able to solve some of the examination numericals. The critical point, as we say, is that point en route from where it takes equal amount of time to come back to my departure base, okay, or to proceed to my destination. In case of an engine failure, or in case of a pressurization failure, or if you have a patient on board, or for that matter any other critical situations. And the formula to calculate the distance to the CP is given by dH upon O plus H, where D is the total distance between the two legs, in this case total distance from the departure to the destination, and H is the ground speed home, and O is the ground speed out, again H is the ground speed home. After having revised ourselves with this formula, we will proceed with the numerical. To calculate the distance and the time to CP from ABC, that is this place at Chennai, and let's assume that Chennai has got a VOR of 116.5, okay, to PQR, in this case this is Bangkok, and with an en route turning point, okay, with a VOR which is XYZ 114.1. The track and the distance from ABC to XYZ is 100,700 nautical miles, and that of the second leg, that is XYZ to PQR, is 075,600 nautical miles. And let's assume the single engine diversion speed is 300 knots of TAS, and in the first leg, that is from ABC to XYZ, you have a winds of 260, 30 knots, and in the second leg, that is XYZ to PQR, you have a winds of 270, 45 knots, and the normal cruising speed is 270 knots of TAS. So in order to calculate the CP, we will have a rough estimation, or we will check, okay, in case if I have to proceed from this point XYZ to Bangkok, how much time will I take, and if I have to come back from XYZ to ABC, how much time will I take. So I will, so that I can take up or strike up the leg which takes a lesser amount of time. So in this case, I will find out the time from XYZ to PQR, where the track is 075 and the distance is 600 nautical miles. And the wind component here, as we said, wind velocity, as we said, was 270, 45 knots. So 45 knots is the wind speed component of it, and the direction, okay, 270. If we reverse it, okay, it becomes minus 180, and the track is 075. So there is an angular difference between the wind velocity and my track is now 15 degrees. So how much will be the wind component? We can find it out by 45 into cos of 15, which is 43 knots of tailwind. So in this leg, I will have a tailwind of 43 knots. So if the TAS we assume, TAS we assume was 300 knots plus 43, so the ground speed out, okay, in case of an engine failure, okay, from XYZ to PQR will be 343. So with this ground speed out, okay, how much time will it take? Okay, can be found out. Okay, but 600 nautical miles is the distance, and with a ground speed of 343 nautical miles, so I will have a time of 1 hour 45 minutes. Now let me proceed to the next leg. Okay, as we have seen that time out from XYZ to PQR is 1 hour 45 minutes. So now I will find out a point, okay, X, I will annotate it X on this particular longer route, okay, longer route, from where it takes equal amount of time for me to come back to my base, that is A, B, C, in the event of an engine failure. So I will choose a point X, which is 1 hour 45 minutes, okay, to come back from X-ray to ABC. The track from XYZ to ABC, okay, will now be 280. And the wind component, okay, the wind velocity given was in the question was, okay, 260, 30 knots. So we will find the component once again. So 30 multiplied by cos of 280 minus 260, which is 30 into cos of 20. So it becomes a 28 knots of headwind. When I'm coming back, it is 280 is my track, and the 260, 30 is the direction of the wind velocity. So I will have a headwind of 28 knots. So my ground speed home will now be 300 knots minus 28 knots, which is 272 knots. So the distance traveled in 1 hour 45 minutes with this ground speed of 272 will be 476 nautical miles. So the total distance from ABC to XYZ was 700 nautical miles. So if I have marked off, okay, a point here X-ray from where it takes 1 hour 45 minutes of time to come back to this base, that is 1 hour 45 minutes, okay, this point is the X-ray. So now from X-ray, if I have to come back to base, it takes 1 hour 45 minutes. Similarly from XYZ, okay, if I have to go back or proceed to PQR, it will take 1 hour 45 minutes. So this two leg, okay, that is 1 hour 45 minutes and the 1 hour 45 minutes now can be neglected. And now we can assume that we are now sure that my CP will lie in between these 2 points. So what is the distance between these 2 points? Is that 700 nautical miles minus 476, which is 224 nautical miles, is the distance between X and the XYZ. So my CP is going to be lying in this single leg. So what I have done is, from a multiple leg, I have cut down all the additional leg and bring that particular numerical to a single leg CP. That is what we have done in the previous class. Okay, I repeat, since it takes 1 hour 45 minutes from X-ray to come back to Chennai, and from XYZ to PQR 1 hour 45 minutes, this particular two leg and the portion, this particular leg can be neglected, and we can consider that my CP will lie in between these 2 points. Now the problem is now simple. It is as good as solving the CP or the equitime point on a single leg. So in this case, if I have to come back from XYZ towards my destination, the ground speed is 300 minus 28. This is what we have found out earlier. Okay, that is 272 knots. And as far as the ground speed out is going out, it is 300 plus 28, 328. With the same formula, what we have done, CP, distance to CP is equal to dH upon O plus H. Okay, the distance left is 224 miles. The ground speed home is 272, and the sum of ground speed out and the ground speed home. So now if we solve this, this becomes 60928 upon 600 miles, which is 102 nautical miles. So therefore my CP, okay, is going to be in between these two. Where exactly in between these two? 102 nautical miles from the position X. Okay, from this point X, my CP will lie 102 nautical miles ahead. after having calculated the distance to the CP, which is 102 nautical mile from the point X-ray, now let us verify our solution. So the distance from X-ray to CP is 102 nautical miles. Therefore, the time from the CP to X-ray, is 102 upon my ground speed home, which was 272. We have seen it earlier, which is going to be 22.5 minutes. And now we will see the time taken from CP to XYZ. So the distance from CP to XYZ will be equal to 224 nautical miles, which was the distance between X and XYZ, minus 102 nautical miles, that is 122 nautical miles. So the distance from CP to XYZ is equal to 122 nautical miles. With ground speed out, which is 328 knots, the time is going to be 22.5 minutes. So it will take 22.5 minutes from here to come back to X-ray, and from the CP to XYZ. And as we have found out that it is going to take 1 hour 45 minutes from here further, so the total time, that is 22.5 plus 1 hour 45, it is going to be total time from CP to PQR. Similarly, it is going to take 22.5 minutes from CP to X-ray, and from X-ray till ABC, it is going to be 1 hour 45 minutes, as we have done it earlier. So it is going to take equal amount of time to come back to base or to proceed ahead. So now let us find out the time to my CP. So now the total distance, okay, from ABC to my CP will be 476. That is 476 is the distance we have found out. That is the distance from ABC to X-ray, okay, plus 102. Okay, this is 102 nautical miles. So therefore 476 plus 102, which is 578 nautical miles. And the time to CP will be using the normal cruise, that is distance upon TAS plus winds. Okay, TAS, which we have considered for a normal engine, was 270. So therefore the ground speed is going to be 298. So in order to travel 578 miles with 298 knots, okay, I will take 1 hour 56 minutes to reach my CP. So now, after having solved the problem of a multiple leg CP, now we will come to another problem where I have a straight leg. However, the winds are changing somewhere in between. So in this case, I'm going to be taking the same example, that is a flight from Chennai to Bangkok on a direct route. So somewhere in a route that is 700 nautical miles from Chennai, let us assume that the winds are changing. The question is going to be like this: calculate the distance and the time to CP from Chennai to Bangkok. The total distance from Chennai to Bangkok is 1200 nautical miles. Engine failure speed is 300 knots. Winds outbound. At engine failure, cruise level is tailwind of 50 knots up to 700 nautical miles, and from here onwards it is 30 nautical knots of tailwind. The normal cruising speed is 270 knots, and the winds, okay, up to 700 nautical miles is assumed to be 50 knots of tailwind, and from 700 onwards it is 30 knots of tailwind. So we will annotate the place where the winds are changing as X, and the distance from X-ray to Bangkok is going to be the total distance, that is 1200, minus the distance from Chennai to this point, that is 700 nautical miles, which is now becomes 500 nautical miles. The ground speed out is tailwind of 30 knots from here onwards. So 300 plus 30, 330 knots. So therefore, the time taken from X-ray to Bangkok will be 1 hour 31 minutes. Now, we will strike out a distance corresponding to 1 hour 31 minutes from a point en route in order to come back to Chennai in case of an engine failure, and let that point be annotated as Yankee or Y. So the ground speed home is 300 minus 50, which is going to be 250 knots. Distance corresponding to 1 hour 31 minutes will be 379 nautical miles. So this Yankee will be at a distance of 379 miles from Chennai. So if we subtract 379 from 700, which is the distance from Chennai to the point where the winds are changing, we are left with 321 nautical miles. And the CP will lie in this segment between Yankee and the X-ray. So as we have calculated earlier that the distance between X and the Y is 321 nautical miles, and the ground speed home is 250 knots, and the ground speed out is 350 knots, and the distance to CP will now be dH upon O plus H. The distance is 321 miles, H is 250, O plus H is 600, so therefore 134 nautical miles is the distance of CP from this point Yankee. So now if we add up to the distance, okay, the distance from Chennai to Yankee was 379, and from Yankee to the CP was 134. So therefore the total distance from Chennai will now be 513 nautical miles. Under this, ground speed out under the normal condition is 270. So therefore the plus 50, so therefore it is going to be 320 knots. So therefore the time to CP is 1 hour 36 minutes. So in the next class, I'll be covering the PNR, or point of no return, or it is also known as the point of safe return, PSR. If you like the video, kindly press the subscribe button and also press the bell icon so that you get a notification timely, and share it with fellow aviators. And I thank you very much, ladies and gentlemen. Have a nice day.